Okay, so here we go. Thomas was asked about a Pearson homework problem from chapter 8, an old chapter, so he's thinking about the final exam, which is a good thing to do when you get a chance to do it. And the particular problem in the book is number 20 on page 529. That section is integration by parts, and I think integration by parts is a good topic to include on the final, so I think this is a super good question. In the textbook problem, there's no 4 here, so I guess the author thinks that they're going to mix it up a little bit by putting a 4 there. But, you know, the 4 is pretty trivial. I hope you'll agree. We can just bump it through the sign. So we know, because Thomas told me, this is from chapter 8, section 2, which means integration by parts. Okay, on the exam, if such a problem would show up, I may say use integration by parts, or I may say find the antiderivative. So we need to think about, you know, what we would do if we didn't know that we're supposed to do integration by parts. And you know, that's more difficult than just using integration by parts. I think once we decide to do it, we can figure out a way to make it work. And so, you know, if we don't do integration by parts, what do we do? Is there like a substitution we can do? Do we know the antiderivative of the inverse sine of x? And I think the answer to both of those questions is no. Integration by parts is the first new technique we learned in chapter 8. Eventually, we learned lots of other techniques. And so on the exam, like I said, it doesn't say maybe integration by parts. So, you know, can we do, is it a powers of sine and cosine? No, it's not, because of the inverse. So we learned a technique for that. It doesn't really apply. Certainly not powers of secant and tangent. We talked about that as well. We don't want to do, the next technique was trig substitution. You know, that was involving radicals and nothing at all that looked like this. And the final technique we learned was partial fractions, and that's working with polynomials. So it appears, if we think about all the things we know, that integration by parts is the only one that has a chance. You know, maybe I can make it easy by saying use integration by parts, but if I don't, we can rule out everything else. So we're just going to bump the 4 out, no problem there. We'll take care of it in just a minute. No, this is one of those unusual ones. We talked about 2 or 3 of them where normally for integration by parts, our function is a product of 2 functions, and we pick one of them to be on the u and the rest of it to be on the dv. Well, the only product here is the 4. We already know how to take care of it. So like this is the antiderivative of one function. I can't put it on the dv. To do integration by parts, I have to split this thing up into a u and a dv. I can't put it over here because finding v would require the antiderivative, and that's what the whole problem is, find the antiderivative. So there's only one way to do it. Put the inverse sine over here, and we'll put the dx over there. And like I said, we're going to just bump the 4 out right here. So there goes the 4. Oh, we should calculate our du and our v first. So the derivative, Thomas, you know the derivative of the inverse sine of x?
Inverse sine of x. 1 over the square root of 1 minus x squared.
Perfect. And v is x. If dv is dx, v is x. So here's a fact that's good for us to know. Thomas, you knew it. Good. The derivative of the inverse sine is this kind of, if you don't pay attention and memorize it, then you would never ever guess it in a million years. You know what it is, so we'll just take special attention. Now we're going to take the 4 out. Then the integration by parts says uv goes in next, x inverse sine of x. And then the whole trade-off integral here is v du. Close paren. So it comes down to us knowing the antiderivative of this guy right here. And if you look closely at it, we have some hope we can figure it out. The derivative of the inside is minus 2x, and I have the x. I can get the minus 2. I can get any constant I want. I can't fabricate variables, but I have the one I need, the derivative minus 2x, and there is the x. So we'll leave the first part alone here. And sometimes I don't write out all the details of the substitution. I'll do it here. So in this integral, we're going to replace 1 minus x squared with u, and then du is minus 2x dx. You see that okay, Thomas?
Yes.
So I get 1 over the square root of u. U is the expression under the square root. And then I built in the minus sign. We're good there. And then the only other thing I need is x dx. And if I divide by -2 both sides, then those 2's cancel. And I get that x dx is equal to minus a half of a du. Close paren. You follow that?
Yes.
Yeah. Now, hopefully, you can see we've done all the hard work. Now, let's write one more step where we kind of clean it up. I don't need the minus 1/2 for this antiderivative. So again, that's a constant. We can push it out. It's going to flip the minus to plus. And then the only thing that's left is 1 over the square root of u. Let's set it up for an antiderivative by writing it as the power function u to the minus 1/2.
Okay.
And then just raise the power. I'll let you finish it. All right. Second question, number 19, page 529. Again, integration by parts. And again, if this problem were on the final exam, I may say use integration by parts, or I may not. But again, just like we did on the last problem, you rattle through the techniques we know, and really none of them even become tempting. But like integration by parts is our only chance. And we're going to violate kind of one principle that we use in integration by parts. Maybe we can write this as like ln x times x to the minus 7. Normally, when we have a power function, we like to put it on the u part because the derivative drives the power down. It's a little bit different also with the negative power. But what we really need to do is put the log on the u part because we know it's derivative. So we can find du. In class, we figured out its antiderivative, but it's not intuitive. And if you haven't paid careful attention, you probably can't just rattle it off. So now we possibly could have to go and dig that up if the first attempt here doesn't work. But here's a general rule for integration by parts. When there is a log involved, we really want it on the u because we know it's derivative. We don't have to think twice about its derivative. We don't want it on the dv. So ln x goes here. And again, let's write it and set up for the antiderivative. And then we find the other parts. The derivative is 1 over x dx. And v is raise the power by 1 from -7 to -6. Divide by the new power. And let's clean that up a little bit, maybe like 1 over 6 x to the minus 6. Okay?
Mm-hmm.
Now let's see what we got. UV minus 1/6 x to the minus 6 minus the integral of v du, which is minus 1/6 x to the minus 6 times 1 over x dx. Notice, Thomas, our trade-off integral, we don't know this one. By integration by parts, we can trade it for that one with this little piece included. And notice there are no logs here. So that's the benefit. You put log on u, and then boom, the log goes away, never to show up again. In
Oh,
integral, it will show up on the first term, but not inside the integral. So that's why we, I mean, there are a couple reasons why we put, if there is a log involved, we really like it to be on the u because we know the derivative, and the derivative gets rid of the log.
okay.
All right, so let's see what we got. Take the minus 1/6 out, so it turns out into plus 1/6. And then I have x to the minus 6 times x to the minus 1, right? 1 over x. I'm going to work this on out, Thomas, and then I'll pause the video. And then if you have questions, we'll talk about it.
Okay.
So finally, you get this written as a power function, raise the power from -7 to -6, divide by the new power. And we get minus 1/36 x to the minus 6. Oh, sorry, Thomas, I made a mistake. So let's go back here. I forgot my v du. So v is 1x. And then what we get is okay. It should squeeze in there as well. So we get plus 1/6 x to the minus 7. Raise the power. And there we go. That should be